Good day everyone, it is Damien here from Aerotherm, and today I'm going to be taking you through a tutorial on how to make a 2D mesh in STAR-CCM+. We are going to start off with our CAD file over here. You can see we've got our CAD model which has been imported as a geometry part into STAR-CCM. We are going to start off by assigning these parts to regions. We're going to create one region for each part, and we're going to create a boundary for each part surface. We can now press apply, and this is going to create regions of our isolated hill CAD. Within this, we are going to set up our boundaries quickly. Here we've got our inlet. We are going to make this a velocity inlet. We've got our outlet, which we are going to make a pressure outlet. And then we've got our ceiling over here, which we are going to make a symmetry plane. I'm not going to delve too much into the details of this because the focus of this video is going to be meshing. However, we will be visiting regions within another video on our YouTube page. Now that we've got our region set up, we can now create a badge for 2D meshing operation. This icon over here. The reason why we do this is because our CAD model is imported in 3D. So in order to set up a 2D simulation, we need to configure our CAD so that it can be meshed in 2 dimensions. So we're just going to press OK over here, and now we can see that our parts has been configured for a 2D meshing operation. So with this set, we can now go and right click on operations, press mesh, automated mesh 2D. We can now select our isolated hill part. We are going to select a polygonal mesher with the prism layer meshing and press OK. This creates an automated mesh operation over here. We can open this up and take a quick look at what we've got. We've got our base size here, which is 1 meter. We've got our target surface sizes. We've got our prism layer controls, our surface growth rate, and we have the option for custom controls. So now, to get an idea of what we need to make our base size of our mesh, we are just going to quickly take our ruler icon over here and measure our way across the CAD domain. This is roughly 3.5 meters. So now we know that our base size of 1 meter is going to be far too large for this domain. So we're just going to quickly experiment and make this 0.1 meters. Now we can just go and quickly execute this to see what is given. We're going to quickly open up a new mesh scene over here, and this gives us an initial mesh. So we can see this is a very coarse mesh. And let's be honest, it's a mesh that we probably would not trust to give us accurate results. So this means we need to now go and refine our mesh. So let's start off by making our base size a little bit smaller. We can see now that we've updated the base size. We've got our arrow, sorry, not our arrow, our exclamation mark over here by our automated mesh, which means that we need to update our mesh. So we can quickly go right click and press execute. This is going to go and give us a finer mesh. However, we can see that this is still quite coarse. So now we're going to just perhaps look at making it a little bit finer again. 0.025, and we can alternatively go and select execute mesh over here. This is giving us a much finer mesh around the boundaries of our domain. But if we look in the middle, our mesh is still rather coarse. Let's give it a quick measure to see how large it is. This is roughly 0.09, 0.1 meters across, which is much larger than our base size. So now we want to put in a volume control to limit the size of the cells within the center of our domain. To do this, we're going to right click, new custom control, and we're going to select a volumetric control. We can open this up and select a part. We're going to select our isolated hill region, and then we can open up our controls. We're going to customize the size of our 2D surface mesher, and then our custom size is going to be relative to our base, and we're going to set this to 100% of the base size. This means that all of the cells within our domain will be no larger than the base size set over here. So we can now go and press execute to update this, and this is already going to give us a much more fine mesh. But now we can go and have a look at other things that need to be refined within this simulation. We can see we've got our prism layers over here, and we've got our hill over here. At this stage, we need to start thinking about how the flow is going to act through our simulation. If you follow my arrow, we've got our velocity inlet over here, where flow is going to go in, and it's going to circulate around the hill. So with this considered, we're going to make some custom controls for our hill. We're going to right click, press new, surface control, apply part surfaces. We're going to open up our region and select our hill. This will give us the option here to customize a whole lot of parameters. We are going to look at customizing our target surface size and make this custom, and we are going to make this 25% of our base size, so 25. We can now go and update our mesh, and we can see the difference that this has made. We've got a much finer set of cells around our hill, but then it is much coarser further downstream and upstream. So we are now going to look at editing the rest of our cells with respect to this. Firstly, we want to look at our prism cells. We can see we've got a big jump in cell sizes over here compared to that of the rest of our polygonal meshing. So we are now going to go and edit our prism layer controls. We want to add in a whole lot more prism layers, and we want them to stretch out a little bit further. So we are going to make this absolute, and we are going to select a thickness of 0.025 meters. Quickly updating this will give us an entirely new set of meshing, and we've got our new prism layers generated over here. So we've now got many more prism layers, but we still have this issue of a big jump in cell size between our prism layer and our polygonal meshing. So to fix this, we are going to go back to our prism layer controls, and we are going to look at our prism layer stretching. We are going to reduce this to 1.2, which makes a 20% stretch factor, and update this again. Looking at this result gives a much better prism layer, but we still do not have a very nice jump between our prism layer and our polygonal meshing. So we're just going to make this ever so slightly finer. Updating this gives us a much nicer transition between our prism layers and our polygonal meshing at our hill. This sorts out much of our prism layer meshing. However, we have still got a problem with our surface growth rate. We can see here we've got very fine surface meshing, but then we jump to much larger meshes, much larger cells further out very quickly. So we're going to go and have a look at our surface growth rate selected over here. And the default setting is 1.3, which is a 30% growth rate. We are going to set a user specified growth rate of 1.025, which is a very slow growth rate of only 2.5% per cell. Updating this is going to give us a new mesh, which, as you can see, is much more fine here. It is much more fine here because we have made all of our surface refinements and our surface controls on the hill. However, further downstream it is still relatively coarse. Looking again at the direction of our flow when it covers the hill, we are going to have our velocity inlet, and the flow is going to come along, and we are going to have a set of gradients representing vortices or so on and so forth further downstream of the hill. So we need to look at refining this downstream area of the hill to be able to accurately capture all the gradients and all the flow patterns that we are seeing downstream of this hill. To do this, we are going to make a new part, select new shape part, and select a block. We are going to decrease the size of our block to the region that we are specifically interested in over here, which is roughly a couple hill diameters further downstream. Now we need to make sure that we have got a 3D part that is created. We can now press create. This is going to give us a block over here. We've got our isolated hill and we've got our block. We can now use this block to create further mesh refinements. So we can now select our custom control under our automated mesh, create a new volumetric control, and then we can go and select a new part over here. We're going to select our block and press OK. We can now go and create a new custom control. We are going to customize our 2D surface mesher. Customizing this size, we are going to look at creating a relative to base size type of roughly 50%. We can now go and execute, and this is going to give us a much finer mesh further downstream, which will be able to better capture the gradients and our flow features downstream. This brings us to the end of our tutorial, where we've got a very basic setup of a 2D meshing configuration. It is very important to remember that if you are doing meshing within an academic or commercial setting, it is important to make sure that you have got mesh independent and use mesh independent studies in order to make sure that you are getting accurate results. However, that will be the content for another YouTube video. Thank you very much. This has been Damien from Aerotherm.